Hello, my name is Robin and welcome to tutorial 2 of how to use SIQ to analyze your NGS data. So here we assume you have SIQ installed and up and running, and what you also need are the FASTQ files which you probably have obtained from your sequence facility, and you need the reference DNA file. And besides that, you need the information about which primers you used and which target site you have used. So let's go to SIQ first. So here on the left you see that you have to input the FASTQ file, and then optionally you have a second FASTQ file, which is normally the case when you have Illumina paired end sequence data. You input both data files, and SIQ will actually automatically merge those reads and then do event classification. So the fields are, the header part of the table here is red because they are not filled in correctly, and SIQ does not accept this as a valid run. So you need at least one sequence file, a reference file, a name, which we call alias here, a left flank and a right flank. And just to remind you of this, how this works, so you need the information about which primer you use to amplify your DNA of interest on both sides, and you need to know the target site. I have created already a snapgene file with all the information that we're going to use, and here I have the input files that I require. These are actually not important, they're created by SIQ, or just remove them. So if you look here on the lower part of the screen, what you now see is the reference piece of DNA, which comes from the HBRT mouse genome. And what I have inputted here using snapgene is the left primer, the right primer. This is the guide RNA that we've used, including the PAM. The PAM is located over here, and normally CRISPR-Cas9 cuts 3 base pairs in front of the PAM site. So here we're at the specified cut site, and what you then use SIQ for is to input the left flank, which needs to be at least 15 base pairs, and the right flank, which needs to be at least 15 base pairs. And the reason that we're not allowing you to input a guide RNA is because we don't want to limit ourselves to only analyzing CRISPR-Cas9 type of experiments, but any type of experiments where you know you make a break at a certain location. So it can also be an IC1 site, for example, Talon, zinc finger, you name it, SIQ can analyze it. That's why we want to actually specify the expected cut site using the left and the right flank. So the cut site is always in between the left and the right flank. Okay, so I have here my R1 and my R2 files, which is just the files that you get from your sequence facility. You can either use SIQ by using select directory to actually get them, but I also like to drag and drop them. So for example, I can drag this R1 file here, and also the R2 file directly. And then this is the reference DNA sequence file in FASTA format. And I will just quickly open it in Notepad to give you an idea of how it looks. And the FASTA format is nothing else than the first line having this larger than sign. Then there's some text, which is just the name of the DNA that you're gonna give it. So in this case, it's just the mouse HPRT exon 3. And SIQ uses this information to use this, uses this text to put it as the subject that it's analyzing. We'll come back to that later. And this is just the reference DNA, which is a small piece of DNA, and it can be upper or lowercase. That doesn't really matter. SIQ will understand that. So we also drag that reference file here. As you see, when I drag it, it actually becomes green. So the alias, we just call it HBRT or wild type. These are wild type cells, HBRT. And then we have to input the more difficult parts. The left flank and the right flank, which I just covered. So I'll just copy that from the snapgene information. So this is the left flank, and I just do it in the forward orientation. See, it also directly becomes green because the reference files is already known, so it actually searches if the left flank can be found in the reference, and that is the case. That's why it becomes green. And then in addition, I'm going to input all the primers. The primers are in fact optional, but if you're doing Illumina type of experiments, I would always include the primers. because we know from experience that this works much better. For the right primer, I'm taking the reverse complement, which is Control-Shift-C, or just clicking here, input it there, and now we are basically ready to go. So SIQ has now everything it needs. It has the files containing all the reads, it has the reference DNA, it knows which names we want to give it, and it has the information about the cut site specified by the left flank and by the right flank, and the primers that were used for experiments. So within the primers, we do not include the flaps that have been used for immunoassay sequencing itself, only the pieces of the primer that actually fit onto the DNA. So everything is done. It says here now 12 CPUs, but because it's only one file that's going to analyze, it's only going to use one CPU, but don't bother with changing that, it will understand that. Okay, we're going to press run, then it asks me where to actually put it. In this case, it's going to be put in downloads, and I don't care so much about the Excel file name at the moment. And like I said, SIQ performs merging of this R1 and R2 file, and if you want SIQ to remerge those files, to recreate those merged files, you have to check the tick box or the checkbox here. Normally that is not required, and if it's not present, it will of course merge it, because then it cannot find it. I'll just leave everything as it is and just press yes, and then the run is started. As you can see, it already analyzed 18,000 reads, of which about 15,000 are correct. About 81% of the reads are correct, and it's now busy writing the output. And as soon as it's ready, it will create the Excel file, and that Excel file we can use later on in SIQ plotter to analyze. If there's a problem with any of the input, they will become red. Some common problems are that the reference file is not in FASTA format, so you can check either by using Notepad or using Snapseed or whatever, check if it's in FASTA format, and the FASTA format specifies that this line needs to be there, so this greater than sign needs to be there, and if it's not present, it will not understand it, so please check that first. If you run into any issues and you don't know how to solve it, please contact us on GitHub, and there's a tab there which says issues, and just input your problem and we will take a look at it to see if we can help you with the problem. Most of the times the red flags, so for example the left flank or right flank, are caused because the DNA sequence is just simply not present in the reference. But everything is fine, everything becomes green and you can run. And if you want to run it again, for example, you can of course do that. I will just not do that right now. And if you want to test if SIQ is actually able to do the analysis on test data, you can always say, first we'll clear the table, but you can also load example data, and then you will see it can analyze many data sets simultaneously. Here you can just press start, and then as you can hopefully also see is that some data sets only have an R1 file, so the R2 file is missing, and it doesn't really care about that, so it's optional, this R2 file. And this in fact is PacBio type of data, and there you have only one sequence file. So here you can see it's almost done analyzing all the reads. For most data sets there's only about 25,000 reads, so it should go fairly fast. As you can see, the writing process takes longer than actual analysis, but as soon as that is done, which will take a few more moments, it will again open an Explorer and show you the location of the data file, which is now here. All these other files are sort of intermediate files. You don't really need them, but they're created anyhow. And here's the Excel file that contains all the information. Okay, that ends this tutorial, and if you have any problems or whatsoever, don't forget to put them in the GitHub issues tab so we can help you further with it. In the next tutorial we'll discuss how you can now use this Excel file, which is the main output of SIQ, to explore your mutational profiles and to make sense of your data. Hope to see you there.